In this video, we'll be using properties of definite integrals. As we go through these, you may want to copy them down in your notes. Our first property, notice that the lower limit of integration and the upper limit of integration are both a. On the second property, notice that the lower limit is b and the upper limit is a. If we wish to reverse those, then that's the negative of this integral. On this one, you'll notice here that both the upper limit on the first integral and the lower limit on the second integral is the same constant. So we can split this function into two regions then this way. Our next property is finding the integral of some constant k times a function dx. And this just says that we can pull that constant k out in front of the integral. This property, we can split that into separate integrals of x. This next property is saying if f is non-negative, in other words, it's above the x-axis on the interval from a to b, then the integral is non-negative as well. And then on this one, if f function is lower than the g function, if we were to look at the graph, then we can also say that the area, or the integral from a to b of f of x dx, is less than or equal to the area, or the integral from a to b of g of x. Let's do a few problems. So our given information, we're asked to evaluate each integral using the following values. The integral from 2 to 4 of x cubed dx is equal to 60. The integral from 2 to 4 x dx is equal to 6. And the integral from 2 to 4 of dx is equal to 2. Our first problem is to evaluate the integral from 2 to 2 of x cubed dx. Now it doesn't matter what our function is, because the lower limit of integration is the same as the upper limit of integration. This value is 0. Our next one, on this one we're asked to evaluate the integral from 2 to 4 of 15 dx. Now anytime we have a constant, we can pull that out in front of our integral. So this is the same as 15 times the from 2 to 4 of dx. Now we know that that integral is equal to 2. So this expression then is 15 times 2, which is 30. And then on this one, we're asked to evaluate the integral from 2 to 4 of x cubed plus 4. We can separate this into two separate integrals. So this is the integral from 2 to 4 of x cubed plus the integral from 2 to 4 dx. We're given that the integral from 2 to 4 of x cubed is 60. So this is 60. And then on this one we have the 4 out in front. And then we can replace the integral from 2 to 4 of dx with 2. So this is 60 plus 4 times 2. This is 8. So we get 68. Do some more. Here we're asked to evaluate each integral using the following values. The integral from 0 to 3 of f of x dx is 4. And then the integral from 3 to 6 of f of x dx is -1. notice that the upper limit of integration on this one and the lower limit of integration on this one are the same. So we're going to use the property that says that this integral from 0 to 6 is the same as the integral from 0 to 3 plus the integral from 3 to 6. We're given that this integral is 4 and this integral is -1, so our integral from 0 to 6 is 3. And then on this one, we have the integral from 6 to 3 of x dx. We know that we can turn these limits of integration around by negating the integral. So this is the same as the negative of the integral from 3 to 6, f of x dx. And we're given that that is equal to -1. So this is -1.